And students, you are welcome to this channel, A-Startutors Academy, where we treat various topics in chemistry and other sciences. Today we shall be looking at a practical question on qualitative or SWOT analysis in preparation for the forthcoming examination for students. We are considering a qualitative or SWOT analysis on a sample labeled C. And here is the question. Sample C is a solid mixture containing a simple inorganic salt and an organic substance. Carry out the following tests on C. Record all your inferences from your tests and observations. Identify any gas or gases involved in the test. Hey, put all of C. Or before we go into that, I would like to explain or expatiate on what we mean by solid mixture. Here we have a mixture of two solid substances. One is a simple inorganic salt and the other is an organic substance. When we talk about a simple inorganic salt, we mean a salt that has only one positive and one negative ions or radicals in it. For instance, like sodium chloride, lead-2 carbonates, and so on. These are examples of simple inorganic salt because they consist of one positive and one negative ion or radical. Then an organic substance such as glucose, starch, and the likes. So here sample C contains one simple inorganic salt and one organic substance mixed together to be analyzed so as to identify those substances in the sample. Now these are the various tests to be carried out on the sample C. We shall be assuming that the sample C consists of lead carbonate and starch. Both of them are white substances. They are white in color. And these are the tests to be carried out under exam condition. Hey, we are to put all of the C into a boiling tube and add about 10 cm³ of the still water. Then shake vigorously and then filter. Keep the filtrate and residue. Now this test A is a solubility test to test if the sample is soluble or insoluble in water. And the essence of shaking is to enhance the solubility of the substance in water. Now don't forget that I said we shall be assuming that that C consists of two white substances, lead carbonate and starch in that C. Now B, Roman figure 1. After filtration, we have to keep the filtrate and residue. Don't forget that in filtration process, we use a filter paper that we fold into a conical shape, put inside a funnel, and place on a beaker or anything that can suspend the funnel. And what you do is that after pouring the water into the mixture into the sample in the boiling tube or any other container, you gradually pour the mixture into the filter paper in the funnel to allow filtration to occur. At the end of this filtration, you have to keep the filtrate for test, and that's where the residue for test. Now I would like to expatiate on this as well. If a white solid dissolves in water, what you should have at the filtrate is colorless. If a white solid substance dissolves in water, the solution should be colorless. But if it is colored, then there will be a color attached to that solution. Now for lead carbonate is a white solid, and starch is also a white solid, and both of them we are to test if they are soluble in water or not. Now after adding water, you filter the mixture, you keep the residue and the filtrate. Now be high, we are to start a test on the residue. To the residue, add dilute HNO3, that is triazonitrate 5 acid, or simply put nitric acid. I would like to explain something here. If a solid does not dissolve in water, which is a common solvent, and there is a need to carry out a test on the solution of that solid, then the next thing that they will have to do is to add acid so that it can give a solution of that solid which does not dissolve in water. Now in this case, residue is a substance, a solid substance, which remains on the filter paper after filtration. So the residue is to be dissolved on adding the dilute HNO3 so that the subsequent tests can be carried out on its solution. And that is the reason why you are asked to add dilute HNO3 to that residue in order to dissolve it. Roman figure 2. To a little portion of the resulting solution from Bi, add sodium hydroxide solution, first in drops and then in excess. Don't forget that the test in Bi is to add dilute HNO3 to the residue, and I've told you the reason why you do that. We need a solution of that residue, and since it does not dissolve in the common solvent, which is water, then the next thing is to add a dilute acid in order to dissolve it. So when you add dilute acid, there will be a solution formed, and that is the reason why the next test, B Roman figure 2, is to carry out a test on the resulting solution from Bi you've performed. We are to add sodium hydroxide solution first in drops and then in excess. Sodium hydroxide solution is one of the commonly used precipitating reagents. Why do you have in drops? You add in drops to know whether it's going to form precipitate or not. And why do you need to add in excess later? You add in excess to know if the precipitate formed in drop will dissolve or not on adding excess of the sodium hydroxide. Don't forget, sodium hydroxide solution is a common precipitating reagent. So we are to add sodium hydroxide solution in drops and then in excess. Roman figure 3. You take another little portion of the resulting solution prepared and be high above, and this time around you are to add aqueous ammonia in drops and then in excess. Just like I said that sodium hydroxide solution is a precipitating reagent, aqueous ammonia is also a precipitating reagent. On adding in drops to the fresh solutions of Bi above is to know if there will be precipitate formed or not. Then on adding in excess, if precipitate is formed when drops are added. Then on adding in excess is to find out if the precipitate dissolves or not. That's a solubility test. Don't forget there are various tests that are required when we are talking about qualitative analysis. One of those tests is solubility tests. We also have other tests and the rest of them. So in this case, we are carrying out solubility tests on adding those reagent solutions. Roman figure 4. You take another little portion of the solution from Bi, that is the solution that you prepared on adding dilute HNO3 to the residue. A solution is expected to be formed. So to a little portion of the fresh solution, you add dilute HCl, then warm gently. And Roman figure C, this is a test on the filtrate. So we are to take a little portion of the filtrate and we add few drops of iodine solution. We all know that we can predict the test or the inference or the ions to be detected from the reagent used. Iodine solution is a reagent used to test for the presence of starch. When we add iodine solution, if it forms a dark blue coloration or blue-black coloration, we know that there is starch present. And if it doesn't, then it confirms absence of starch. These are the tests that are expected to be carried out on the sample C. Now let's see, how do we write our reports? I would like us to pay attention here, because there are certain things that students fail to write when they are writing their reports in qualitative analysis that makes them to lose some marks. So I want us to pay attention to what I'll be explaining as I write the solution to this test. On this column, you write test, observation from the test you carried out, and inference. That's the conclusion of the test and observation carried out from the analysis. Now, test A. We are to add the C to water. So C plus distilled water. C plus distilled water. Shake. You have to shake. You write all these keywords. Shake and then filter. These are what you are to carry out in A. When you add the still water to the sample, either in a beaker or conical flask or boiling tool, depending on what is provided for you, you are to shake vigorously. The essence of doing that is to enable the substance to dissolve if it is soluble. But if not, it remains insoluble. Now, when you add water to this sample C and you shake, what you are going to observe is the sample will remain insoluble. Sample remains insoluble. It does not dissolve. And it forms white cloudy suspension. A white cloudy suspension will be formed. A white cloudy suspension will be formed. On filtering, on filtering the mixture, on the filter paper you have a white residue. You have white residue and slightly cloudy filtrate. cloudy filtrate or turbid filtrate. Slightly cloudy or turbid. Turbid, just choose a word. Make sure you maintain those key words to fully describe the filtrate and the residue. The color test, the solubility tells. These are the key words that the examiner will be expecting from you to write in your report. So, and a white residue and slightly cloudy or turbid filtrate will be formed or obtained. Now, why is it cloudy? Why is the filtrate not clear or not colorless as expected? It's not so clear because some particles of the starch dissolve in water, which comes out through the filter paper with the filtrates, and that is the reason why the filtrate is not as clear as one would have expected, but rather is cloudy or turbid in appearance. That's the nature of the filtrate obtained. Now, what will be the inference from the test and observation? You write that C is a mixture. C is a mixture of two insoluble substances. Two insoluble substances. The starch and the lead carbonate, both of them are not actually soluble in water, but some particles of the starch dissolve in water to give us a colloidal suspension in water. That's why the filtrate that is collected through the filter paper, that flows down through the filter paper, is cloudy in appearance. Most of the starch and the lead carbonate remains in the residue on the filter paper. So both of them are not soluble in water. They are not soluble, so they remain as residue. But few particles of the starch, dissolve in water and comes out as a cloudy filtrate. So this is the first test, which emphasizes solubility tests and color tests. So when you are writing your report, it is very important to indicate the key words. White residue. The white must be there. You must be able to state the color of the residue that you obtain, that you observe. And also the filtrate. You need to describe how it looks like. The filtrate is also slightly cloudy. Filtrate is slightly cloudy in appearance. It looks slightly cloudy, not so clear as water that you would have expected. So that is the first test. Let's go to the next test. You rule a line so that there won't be your report will not be muddled up. Separate the test, and when you're writing your test and inference, you write your test and inference in such a way that it will correspond to your observation and inference, rather in such a way that it must correspond to the test you carry out. Your observation and inference must correspond to the test you carry out. Don't mix them up. Now, after that test, before the next test, try to leave a line or rule a line. And let's go to the next test. What is the next test? The next test we are to carry out is on the residue. To the residue, add dilute HNO3. So in the test column, write this. You write this: residue residue plus dilute HNO3, dilute HNO3. You are to add the acid, the dilute HNO3, to the residue in the boiling tube or whichever container that is containing that residue. And what are the things when you add the dilute HNO3? Effervescence will occur. Effervescence means evolution of a gas during a reaction that occurs in aqueous state. When a gas is released during an aqueous reaction, you describe that as an effervescence. Effervescence occurs. And that means you need to describe the gas you observe. And the gas you're observing is going to be colorless. So a colorless, that's a color test. Observe the color, the odor. There is a way you blow the gas towards your nose. Don't put your nose directly on the reaction tube, the boiling tube or any container where the reaction is carried out. It's not ethical. So you blow gently towards your nose to perceive the odor of the gas. So the gas that will be released from this reaction is colorless and odorless. It's a colorless and odorless gas. A colorless and odorless gas is released. Or is evolved. And not only that, during this test, whenever you are carrying out a test that you know that a gas will be released, always get your litmus papers, moist blue and red litmus paper ready. Don't carry out a reaction, especially when you are adding acid to a solid substance. You should always expect that it's most likely that a gas will be released. So get your moist blue and red litmus paper ready. What do I mean by moist litmus papers? That is litmus papers that are not dry. So don't just get only one, you get the two. Hold the two in such a way that they will not rest on each other. Hold the two litmus papers that are wet or moist in such a way that they will not rest on top of each other. They should be free so that they can dictate the gas that is coming out from the reaction container or test tube. So hold the two litmus papers, suspend them at the mouth of the boiling tube or whatever container that you are using where the gas is released from. And what we should observe is the gas. The gas will turn the moist blue litmus paper red, slightly red. Gas turns moist. Put the word moist or damp. If this word is not mentioned, there will be no mark. Moist or damp blue litmus paper. Blue litmus paper. It turns the blue litmus paper slightly red. Even if you don't put slightly, if you put the color test, with or without the word slightly, but as long as the correct color that is changing to is mentioned, you score your mark. But let me put it slightly. It turns the moist or damp blue litmus paper slightly red, not so deep. That's why it is slightly, but the color is mentioned, so you score the mark for that color if it is correct. And not only that, we also use lime water. The gas also turns. It turns lime water milky. It turns lime water milky. Lime water is a saturated solution of calcium hydroxide in water. Lime water is a saturated solution of calcium hydroxide in water. We all know what we mean by saturated solution. When you are adding a particular solid substance into water, keep adding and keep adding to get to a point that it will no longer dissolve. That means it has reached its saturation level. Then we decant or filter it. The solution, the filtrate that we obtain is a solution of the calcium hydroxide. So the saturated calcium hydroxide solution is what we know as lime water. When a gas is passed gently into lime water and the lime water turns milky, it's a confirmation that the gas is carbon dioxide, CO2. This is a confirmatory reagent for CO2. It is only CO2 that turns lime water milky. So whenever you are performing a test on a gas with lime water, how do you do that? You can do the lime water test with the help of a glass rod. Just dip the glass rod into the lime water and suspend the glass rod that is stained with the lime water on it at the mouth of the boiling tube or the test tube or whatever container that you are using to perform this reaction. Suspend it at the mouth. If you are very observant, watch closely, observe closely what you see on the glass rod that is stained with the lime water. You will see that the body or the glass rod looks whitish. It looks whitish. That's the simplest way of carrying out lime water tests on the gas. There's another way you can do it, but that may be too complicated, especially during exam condition. So any gas that turns lime water milky is no other gas than carbon dioxide, CO2. Now, if you look at this observation, there are three tests that are combined together. Number one, color test. In fact, we have more than three. We have color test. We identify the color of the gas. Don't just say gas is released. What's the color of the gas? So number one thing that we reported here is the color test. You must state whether it is colored or colorless. There are some gases that have color. Majority of the gases are colorless. Now, one of the colorless gases is carbon dioxide, colorless. Number two test reported here is odor test. The gas is odorless, no smell. Number three is the litmus test. The gas turns moistened blue litmus paper red. You know what that means? It means that gas is acidic. And number four test reported here under the observation is the lime water test. So these are the four tests that confirms that the gas liberated from the reaction carried out on adding dilute HNO3 to the residue, that the gas is carbon dioxide. Now, what are the inferences you write? Now, the first thing that you write is the gas is CO2, the CO2 gas. How do I know? From the lime water test. It is not enough to say it's CO2 from the litmus paper test, because there are some other gases that are acidic. But the only gas that turns lime water milky is CO2. It's a confirmatory test for the gas. Every gas has its confirmatory test to distinguish it from other gases. So for CO2, the use of lime water is a confirmatory test or confirmatory reagent to confirm that the gas is carbon dioxide if it turns the lime water milky. So the first inference or conclusion is the gas is CO2. It is not enough to stop there. The CO2 gas is from what kind of source? You write the gas is from CO3 minus, or let me first write this, that the gas is acidic. This is the first thing you write from the litmus test you carry out. That's the first thing. We have been able to confirm that the gas is acidic because it turns the blue litmus paper red. Then from the lime water test, which is tested positive, they will say that it is CO2 gas. The gas is CO2. CO2 for what kind of salt? You must write the kind of salt that liberates CO2 by action of dilute acid on it. So the action of dilute HNO3 on that residue liberates CO2. That means the residue that reacts must be a CO3 2 minus salts. So it is CO2 from CO3 2 minus salt. Don't put HCO3. Don't put this. If you put this, you are wrong. Let me explain why you should not include that. You don't include that because from the onset, the residue does not dissolve in water. Now, all hydrogen triazocarbonate 4 salt are soluble in water. So if the sample C contains hydrogen triazocarbonate 4 salt, if the inorganic salt had been hydrogen triazocarbonate 4 salt, then it will have dissolved in water from the solubility test we carried out in test A above. But because the C does not dissolve, it means the inorganic salt present in that C is not a soluble salt, and that means it can't be hydrogen triazocarbonate salt, because from the solubility test of salt we are made to know that all hydrogen triazocarbonate 4 salt are soluble in water. So technically, if you put HCO3 in your inference, it will nullify that point. Then you score no mark. So do not add this. Do not add hydrogen triazocarbonate 4 anion. So it is only CO3 2 minus triazocarbonate 4. So that means the CO2 is liberated from the reaction of the triazocarbonate 4 salt with dilute HNO3. Then that means we've been able to confirm the anion contained in that residue, and that is CO3 2 minus is present. The inorganic salt is a triazocarbonate 4 salts from the test and observation carried out. That is for test B high, the first test B high. Now let's go to the second one. Don't forget that you leave a line or you draw a line before the next test. The next test is BII. Let's go up and see what is the test to carry out. We have to take a little portion of the resulting solution from the BI above. From this BI, we have to take a small portion of the solution. Don't forget that the reason why we are adding dilute HNO3 to the residue, as I explained, is to prepare a solution of the residue for the subsequent tests that will be carried out on it. The subsequent test will be carried out on the solution of the residue. But since it does not dissolve in water, then we need to add an acid to dissolve it. We call it acid digestion, to dissolve the residue so as to get a solution of it. Now, a little portion of the solution is to be taken. Now, let me say this. Why performing this test? These are some things you will notice. When you add a dilute acid to the salts, to the residue in the boiling tube, the substance will not dissolve completely. Take note of what I'm saying. The substance, the residue, will not dissolve completely in the acid, but there will be evidence of reaction. Why is it that it won't dissolve completely? In fact, when it dissolves, it's going to form a kind of suspension. It will be looking whitish suspension. But if you observe it closely, you will see bubbling taking place. That means reaction is ongoing. The reaction is ongoing. Bubbling will be taking place. It's a sign that a gas is released from that reaction. But the substance, the mixture, will look cloudy. And what is the reason for that? It's because of the presence of most of the starch. The starch is still in that residue. It is not only the inorganic salt. There is still presence of most of the starch in the rest. Only few amount of the starch will dissolve in the filtrate. So the mixture you obtain when you add dilute HNO3 residue will not give you a colorless solution. It will not give you a clear solution like a colorless solution, no. And that's because of the presence of the starch particles. Most of the starch particles will interfere with the dissolution of that salt. Normally, if a white substance, a white solid should dissolve in water or anything that is aqueous, like the aqueous acid, it should dissolve to give a colorless solution, clear colorless solution. Any white solid, if it dissolves in water or any aqueous solution like dilute acid, it should give a colorless solution. But if it doesn't give a colorless, if it doesn't form a colorless solution, then there must be some interferences. There must be the presence of an impurity in that particular solid. Like starch will interfere with the solubility or the solution of the inorganic salt in the acid. It will make the residue to completely dissolve to form a colorless, clear solution. So if you are carrying out this test, don't expect that the residue will dissolve and form a colorless solution like water. No, because of the presence of the starch. So it's going to form a cloudy suspension. Cloudy suspension will be formed, but there will be reaction taking place. So what do you do when you come across this? Allow the mixture to stay for a while. Allow the mixture to stay for a while. Most of the particles, the white particles, will settle at the bottom of the boiling tube or the test tube that you are using. You only need a solution, just more of it. Some of the residue, precisely the inorganic salt, will dissolve in the acid. So there will be a mixture of undissolved particles of the residues and a solution at the upper layer, on allowing the mixture to stay for a while, to stand for a while. The particles will settle at the bottom of the test tube or the boiling tube, while the solution at the top, clear solution, the supernatant, will be observed. So what you now do is carefully decant or filter a small. You just need a small portion of it, not so much. Just not so much. You see, when you're carrying out, qualitative analysis, you don't need to take much of the substance or the solution, except when it is necessary. Just a little of it is okay. You don't have to take too much of it. So you don't really need much of this liquid layer, which is a solution of some of the inorganic salt. So take a small portion of the liquid layer, which is almost clear and colorless. Take a little portion of it, for the further test you have to carry out on the solution, because you have to carry out a test on the resulting solution that will be formed on adding dilute HNO3 to the acid, to the residue. So take a small, you can decant or you filter. All you need is just a small solution formed from that in that mixture. Then take a little of it and continue the test. So what are we to add? You have to add sodium hydroxide solution first and foremost in drops. Don't forget I told you something about sodium hydroxide and aqueous ammonia. They are two commonly used precipitating reagents. That is, on adding them to a test solution, they form precipitates. So when you add sodium hydroxide in drops, it's either a precipitate is formed or not. So you add in drop to know whether there is be precipitate or not. So when you add in drops and precipitate is formed, the next thing that you do is to add more of it. You add in excess, and that is to find out if the precipitate would be soluble or not. Solubility test again. Now let's write the reports. Right, residue plus residue plus residue plus dilute HNO3, residue plus dilute HNO3. Okay, sorry, we have done that. This is resulting solution of the residue above plus sodium hydroxide. When you write the formula, don't forget to write AQ, this state symbol, the symbol of the state of that sodium hydroxide. In what form is it used? Failure to put the state symbol AQ, meaning aqueous, will score no mark. It will disqualify even the observation and the inference, even if they are correct. Theoretically they are correct, but it will be penalized and it will be disqualified as a wrong test. So remember to put AQ to indicate the state in which the sodium hydroxide is used. The sodium hydroxide is a solution, aqueous solution. But instead of writing the word, you can write AQ. And if you don't mind, you can still write solution, sodium hydroxide solution. But make sure you put either AQ beside the formula of the sodium hydroxide or write solution in words. It is very, very important. These are little things that make some students to lose so many marks. So write sodium hydroxide in drops. First, when you add in drops, what should you observe? White precipitates will be formed. White precipitate will be formed. Now let me say this. Don't just write a single ion, because you don't even know what the sample C contains. It is from your test that you'll be able to infer or conclude that these ions and that ions are present, or it contains this component ion or whatever. But don't just write a single ion as your inference. You think of what are the ions, which ions gives white precipitates on adding sodium hydroxide. We have the following. We have lead2 Pb2 plus or Zn2 plus or aluminium ion or calcium ion. One of these is present. So either Pb2 plus or Zn2 plus or Al3 plus or Ca2 plus is present. Don't just conclude and say it is lead. You are not yet sure. So it's not yet lead until you have been able to carry out sufficient tests, to confirm that. So when you add sodium hydroxide in drop to any test solution of an unknown substance or salts, if white precipitate is formed, these are the ions that you write. These are the possible ions. Pb2 plus, Zn2 plus, Al3 plus, or Ca2 plus. One of them is present. Then don't forget, rule the line. Then add excess to the same mixture. Add excess of that sodium hydroxide solution. Now, when you add excess, if the precipitate dissolve, because the precipitate will dissolve, precipitates dissolves. When precipitate dissolves, it must give a solution. Like I told you, if a white substance, a white solid dissolves in a solvent, either water or aqueous reagent solution that we are using, the white substance will dissolve to form a colorless solution. So complete that statement. Precipitate dissolves to give a colorless solution. That's color test again, and solubility test together. Is dissolved to give a colorless solution, not just a solution, to give a colorless solution. Again, what are the ions? What are the ions among these that will give white precipitate which dissolves to form colorless solution? We are going to have Pb2 plus, or zinc, or aluminum. One of them is present, but these are the three. Calcium is removed because calcium would not dissolve. Calcium ion forms insoluble white precipitate in excess sodium hydroxide. Now we are done with that test. Let's go to the next test. The next test, we are using another precipitating reagent, which is aqueous ammonia. Aqueous ammonia is also a common precipitating reagent used in qualitative tests or qualitative analysis. So another refreshed portion of the resulting solution formed. Resulting solution plus, that's add aqueous ammonia. Aqueous ammonia falls in drops. When you add in drops, what would you observe? White precipitate to be formed. White precipitates will also be formed. White precipitate will be formed. And what are the ions? The three ions still give the same positive results. Either this, or aluminum ion is likely present. And let me also sound a note of warning here. Whenever you are writing your inference, don't forget that the positive ion we are expecting should be 1, because it's a simple salt, simple inorganic salt. So a simple inorganic salt has one positive radical or ion and one negative radical or ion. Now, don't use and when you are writing a list, when you are listing the ions. Don't use and. Never say Pb2 plus or Zn2 plus, and don't use and, because it's only one of them. We are still debating which of them is likely present. We will later confirm the one that is actually present, having carried out sufficient tests, adequate tests to confirm one of these ions that is present. But in this case, when you add aqueous ammonia in drop to the solution of the unknown salt and white precipitate is formed, the three of them, they give the same result. They rule a line, add excess, write that, add excess of the aqueous ammonia. Don't forget, you must put the state symbol, indicate the states of that substance that is used as a solution. Ammonia, ordinarily ammonia is a gas, but when it is a solution, aqueous ammonia is a solution of the ammonia. Put aqueous, put AQ to indicate that it is not in gas but in aqueous states. When you add excess, this is what you are going to observe. Precipitate will remain insoluble. The precipitate that is formed in drops will remain insoluble. When you carry it out, will remain insoluble. Precipitate remains insoluble on adding more of the aqueous ammonia. And which ions gives this result? It's either Pb2 plus or Al3 plus. So both of them, but one of them is the one we are actually trying to dictate. So Pb2 plus or Al3 plus is present. Rule a line to indicate that the test is done. Roman figure 4. Let's look at the next test to carry out. We take a fresh portion of the solution prepared from the residue, and this time around we are adding dilute HCl and warm gently. Dilute HCl and you heat, you warm. When you add dilute HCl, hydrochloric acid, what will happen? When you take a fresh solution of the residue in the test tube, just take a little. Don't forget, when you are taking a portion of the solution, just need a little of it, not too much. It's not when it is plenty that will give the result or not. We only need little of it that will be quick reaction. So take a little of every solution except otherwise stated. But most cases, you take a little portion of the test solution, the solution that you are testing. Take a little portion of it. Now, the resulting solution from Bi, resulting solution from the resulting solution from Bi above, we are to add dilute HCl. Dilute HCl. Sometimes they can ask you to add dilute H2SO4. They want to confirm something. This test is a confirmatory test. We want to confirm whether it is lead-2 ion or aluminum ion that is present in that salt, the inorganic salt. Now, if it is lead-2, it's going to form a white precipitate, which when you heat, the white precipitate will disappear. On cooling, it will reappear. When you warm, it will disappear. At higher temperature, when you cool it, it will reappear. When you observe such, when that is what you observe, it confirms lead. But when you add dilute HCl to the solution and it does not form white precipitate, then it is not lead. So if it is lead, this is what you are going to see. When you add dilute hydrochloric acid to that solution from the residue you are prepared, white precipitate. White precipitates will be formed. On adding dilute HCl to the solution, white precipitate, is formed. Now, when you heat gently, when you heat, the white precipitate will disappear, will dissolve. White precipitate dissolves on heating, dissolves when hot, dissolves or disappears. Dissolve when the mixture is hot, but when it is cool or cold, it reappears. But reappears, you see it back, but reappears when the mixture is cold. When cold, it reappears. So what kind of substance behaves this way? It must be a salt, a chloride of lead. So what are you going to write as inference? You have to write inference based on the precipitate that is formed, which dissolves when the mixture is hot and reappears when the mixture is cold. You identify that precipitate. What precipitate is that? The precipitate is lead 2 chloride, PbCl2. That's the precipitate that behaves such way. That's the precipitate. When PbCl2 is heated, it dissolves. When it is cold, it reappears. Add lead 2 chloride to water. Heat it for some time to dissolve. If not completely, most of it will dissolve. Depends on how long you heat. But this quantity of the lead 2 would have reduced appreciably, if not totally dissolved. So when the quantity reduces, it shows that it's dissolving. So the lead 2 chloride is a kind of salt that its solubility varies with temperature change. It dissolves when the mixture is hot, but on cooling it reappears. So the precipitate behaving that way is lead 2 chloride, and that simply confirms, it's a confirmation. So it confirms that it is not aluminum chloride. Aluminum chloride is soluble in water, even at normal room temperature. It's a soluble salt. Aluminum chloride is one of the chloride salts that are soluble in water. But lead 2 chloride is an insoluble chloride salt. So this confirms that the ions that is in the inorganic salt in sample C is lead 2. So lead 2 is now confirmed. Is confirmed from the test Roman figure 4. Is now confirmed. We are done with this. The next test is the filtrate test. We are done with the residue test. Now the filtrate. The filtrate is just one single test using iodine solution. Don't forget, by reagents, a student should be able to predict what ions are you likely detecting or testing for, or what is the substance that you are likely detecting. If you are asked to use iodine solution, you are adding iodine solution. Iodine solution is a confirmatory reagent for starch. If it forms blue-black color, it confirms it's a positive test to show that starch is present. But if it does not form a blue-black color, it confirms that starch is absent. So the reagent is confirming the presence or absence of what you are actually testing for, what that reagent is being used for. Iodine solution is associated with starch test. If it is blue-black coloration it forms, it's a positive test to show that starch is present. If it does not give a blue-black coloration, it shows that there is no starch. So when you add iodine solution to the filtrate, if starch is present, then blue-black or dark blue, blue-black, or you can say dark blue, either of the two, dark blue coloration is going to be seen, and that is confirming the presence of starch. So there is starch in sample C. There is starch in sample C. These are the various tests carried out on sample C to identify the two substances that are in the mixture. Now from this table of reports, we have been able to confirm that the inorganic salt is lead 2 carbonates, while the organic salt is starch. So it means starch C contains PbCO3, lead 2 triazocarbonate 4, that's the inorganic salt. This is inorganic. That's the inorganic salt. It's a salt. Inorganic salt is white in color. inorganic salts, and starch. Starch is not a salt, but it's a substance. So be careful not to use salt to describe starch. It's not a salt, but you use the common word, the general word substance. Whether it's a salt or not, both of them are substances. But precisely, the PbCO3 is a salt. It's a substance that is also a salt. Why the starch is an organic substance, it is not a salt. It is not a salt. Don't name it or don't call it a salt. It's not a salt. It's not a salt. It's a substance. It's an organic substance. So this is what we have in these are what we have in sample C. Now I want to make some notes, some things clearer here. We need to understand the following, that when a mixture of lead 2 carbonates and starch is added to water, number 1, the mixture will appear cloudy or milky white. The mixture will appear cloudy or milky white because both of them are white and they are both insoluble in water, except that very little amount of the starch can dissolve in the water. But since it is very insignificant, so we still say that it's not soluble. So when a mixture of lead 2 carbonates, that's PbCO3, and starch is added to water, number 1 thing you should observe is that the mixture will look cloudy or milky white. The second thing that you should observe about the mixture is that the lead carbonates will remain insoluble but will settle on standing for a while. When you allow the mixture to stay, maybe the mixture in the boiling tube or the conical flask or whatever that is holding the mixture, when you allow it to stand for some time without disturbing, the lead carbonate will settle at the bottom of that container after standing for a while. Number 3 thing that you should observe, you should take note of, is starch forms a colloidal suspension in water. Starch forms a colloidal suspension. Colloidal suspension is in water. And that's the reason why the mixture is said to be a suspension or a colloid mixture. It's not colorless. When you add water to the mixture of lead carbonate and starch, it's going to give you colorless as clear as water. It's going to be as clear as water. No, it won't. To form a suspension, suspension will be formed. It's just that when you allow the suspension to stay for some time, that's why on that practical, during the practical, when you add water, allow the mixture to stay for some time, for a few seconds, so that you can get the liquid layer separated from the remaining solid, because the liquid layer is what you are going to test as filtrate. You filter, then you get the filtrates out, and that's why you have to filter. So, but initially the mixture will look whitish, will look cloudy and milky white. The second thing I want you to observe here in this test is this: when the mixture is later filtered, number 1, the lead carbonate will remain on the filter paper as a white residue because it is not soluble in water. 2, most of the starch particles may also partially remain on the filter paper. Most of the starch will be on the filter paper with the lead carbonate. However, few particles, just few particles will escape with the water and be collected as precipitate. Few particles will escape with the water and will be collected as precipitate. But most of the particles that are large enough will remain on the filter paper So that's why the residue is a mixture of the lead carbonate and starch. It's a mixture of lead carbonate and starch, and that's the reason why when you add water, it will not form a clear solution, or colorless solution rather. Number 3, the liquid that passes through the filter paper is what we call filtrates. It's what we call filtrates. And that is the reason why when you are writing your reports, where you carried out filtration, you must indicate the keyword residue and filtrates. Residue and filtrates. If you don't mention those words, it's most likely that there will be no mark awarded. So there will be no mark. So don't just say white substance or a colorless liquid. The colorless liquid could be water or a solution. So if it is water, there is not a filtrate. It is when something dissolves in the water that you have a solution. And the filtrate here is not just water. It is a solution. It is a solution. So you mention the keyword filtrate. That indicates that you perform filtration. And may I also say this, when you're writing your report, if you do not indicate that you carry out filtration, the word filter is not mentioned or filtration is not mentioned. Even if you write white residue and so filtrate without indicating in your report that you carried out filtration, the examiner must see that you carry out filtration. And how would the examiner know? The word filtration or filter must be indicated either under your test column or the observation column. If the word filtration or filter is outrightly missing, then all other things, even though they are correct, they are just theory. The examiner will ask you, how did you get your filtrate? How did you get your residue when you do not carry out filtration? So you won't be there to tell the examiner that I carried out infiltration. It is what you write that the examiner will mark. So whatever you write, explains yourself. So what you write is what the examiner will rank. So if you don't indicate filter or filtering or filtration, at least you must indicate that there is a filtration carried out. You carried out filtration for you to have residue and filtrate separately. So don't forget the keywords. Indicate that you filter. And that is when your observation will be marked correctly. White residue and slightly cloudy filtrate residue. Those keywords are important. So the filtrate is the liquid that passes through the filter paper during filtration. Number 4 that I wanted to take note of is that the filtrate is usually clear or slightly cloudy. The filtrate is slightly cloudy water, slightly cloudy, and that's due to the presence of some particles of starch that are present in the water. So the filtrate becomes cloudy because of the tiny particles of starch that pass through the filter paper with the water. Tiny particles, very tiny particles of starch that pass through the filter paper with the water makes the filtrate that is collected not to be as colorless as water that one would have expected, but cloudy in nature. The particles are too small to be completely trapped on the filter paper. That is why they come out through the filter paper. And when they come out through the filter paper, they are dispersed throughout the water, making it look like colloid, making the water look colloidal. Because some particles pass through the water but are too tiny and light to settle, they are dispersed in the water, throughout the water. That makes it look cloudy. So during the practical work, number 1, take note of the keywords. Don't miss out the keywords, those keywords that I mentioned. Number 2, Make sure you indicate the state in which every substance is used or tested. If you are testing residue solution, don't say residue. Residue plus sodium hydroxide solution. It is a wrong test. So your test must be correctly and clearly stated to score mark. If your observation and inference are correctly stated, before the examiner will mark them, the examiner will look at the test. If your tests do not correspond, do not agree with your observation and inference, then you lose mark for the observation and inference, even though they are correct on paper. But practically, the test that is wrongly stated will make the candidate to lose marks for the observation and inference. So the examiner will consider the test before marking your observation and inference. Don't forget the keywords. Don't forget the keywords and the symbols correctly. Your formula, if you don't know how to write the formula of those substances, write in words. If you don't know how to write the formula of sodium hydroxide, write sodium hydroxide in words. Write the names correctly if you don't know how to write the chemical formula. But it will have been better to know how to write the formula to save time and also save space for you. So this is the end of the explanation of the qualitative practical for the forthcoming exam. Wish you best of luck. Don't forget to subscribe to this channel and share and make your comments. I remain A-Startutors Academy. So look forward for the next video. Thank you.